Good morning. Today we are going to discuss problems on compaction of soil. Here it is the first question for you. Find the maximum dry density for a soil sample having specific gravity of 2.7 and optimum moisture content is equal to 16%. We have given specific gravity is equal to 2.7 and optimum moisture content is equal to 16%. Then we are having the expression rho d max is equal to G rho W by 1 plus E. Here we have to find the maximum dry density. Then take S is equal to 100%. Then rho d max is equal to G rho W by 1 plus G W. Then by substituting G is equal to 2.7 into rho W, density of water is equal to 1 divided by 1 plus G 2.7 into water content. Here it is given as 16%, that is 0.16. Then we are getting a value of 1.885 gram per centimeter cube. Here actually the degree of saturation is not given and we are taking it as S equal to 100%, that is S equal to 1. Then we are obtaining theoretical maximum dry density. Okay, please note down it. Our second question is a laboratory compaction test on soil having specific gravity G equal to 2.68 gave a maximum dry density of 1.82 gram per centimeter cube and a water content of 17%. Determine S, degree of saturation, AC, air content, and Na, percentage air voids at maximum dry density. What would be theoretical maximum dry density corresponding to 0 air voids at optimum moisture content? So, here we have to calculate degree of saturation, air content and percentage air voids. Beyond this, we have to calculate theoretical maximum dry density, that is corresponding to degree of saturation is equal to 100%, or we can say percentage air voids Na is equal to 0. So we have given G is equal to 2.68, rho d max, maximum dry density equal to 1.82 gram per centimeter cube, and water content is equal to 17%, which is equal to 0.17. So we are having expression of maximum dry density rho d is equal to G rho W by 1 plus GW by S. From this 1 plus GW by S equal to G rho W by rho d. Then by substituting G as 2.68 into rho W is equal to 1 divided by rho d 1.82, we are obtaining value of 1.485. Then GW by S is equal to 1.485 minus 1, which is equal to 0.485. From this, S is equal to GW by 0.485. G is equal to 2.68 into 0.17 divided by 0.485. S is equal to 0.94, which is equal to 94%. Then we have to calculate air content. We are having an expression connecting air content and degree of saturation as air content is equal to 1 minus S. Here we have obtained S equal to 94% or 0.94. Then by substituting 1 minus 0.94, which is equal to 0.06, that is equal to 6%. So air content is equal to 6%. Then we have to find out Na, that is percentage air voids. Then we are having the expression rho d is equal to 1 minus Na into G G rho W divided by 1 plus GW. From this 1 minus NA is equal to rho D into 1 plus GW by G rho W. Then by substituting rho D is equal to 1.82 into 1 plus G 2.68 into water content 0.17 divided by G 2.68 into rho W, density of water, which is equal to 1. Then 1 minus Na is equal to 0.99. Then Na is equal to 1 minus 0.99, which is equal to 0.01 and is equal to 1%. So percentage air voids is equal to 1%. Next, we have to find out theoretical maximum dry density corresponding to 0 air voids at optimum moisture content. So here we have calculated a degree of saturation value of 94% and percentage air voids value of 1%. So it is the actual condition. But we have to find out the theoretical maximum dry density corresponding to 0 air voids at optimum moisture content. Then we are taking Na is equal to 0 or S equal to 100% or S equal to 1. Then by substituting in the expression rho D is equal to G rho W by 1 plus GW. G is equal to 2.68. Rho W is equal to 1 divided by 1 plus G 2.68 into optimum moisture content, that is our water content, is equal to 0.17. Then we are obtaining a value of rho D is equal to 1.84 gram per centimeter cube. Here it is the question for you. The following are the results of a compaction test. We have given that mass of mold plus wet soil in gram 2925, 3095, 3150, 3125, 3070, and the corresponding water content in percentage is given as 10%, 12%, 14.3%, 16.1% and 18.2%. We have also given that volume of mold is equal to 1000 ml and mass of mold is equal to 1000 gram, and also specific gravity of solids is equal to 2.7. Then we have to find the compaction curve showing optimum moisture content and dry density maximum, and then plot 0 air void line. And third question is determine S, degree of saturation at maximum dry density. So here it is, we have given that the mass of mold plus wet soil. From this we have to find the weight of wet soil only. For that we have given mass of mold is equal to 1000 gram. So from these values, by minusing 1000 gram, we are obtaining mass of wet soil only. Those values are listed here. 2925 minus 1000 equal to 1925. 3095 minus 1000 equal to 2095. Likewise, we have calculated these values, that is mass of wet soil. Then we have to find out dry density. We are having an equation connecting dry density and moist density or bulk density, which is equal to rho divided by 1 plus W, that is water content. Instead of bulk density or moist density, we can substitute M by V, that is mass of wet soil divided by volume of the mold into 1 by 1 plus W. Here we have volume of mold is given as 1000 ml. Then we can substitute instead of volume, which is equal to 1000 ml. Then our equation for dry density becomes capital letter M divided by 1000 into 1 plus W gram per centimeter cube. By substituting in this equation, we are obtaining dry density values. For example, M is equal to 2095 divided by 1000 into 1 plus W. Here the water content is 12%, so here we are substituting 0.12. We are obtaining a value of dry density 1.87. And another example is substitute mass M equal to 2150 divided by 1000 into 1 plus W. The water content corresponding to the mass 2150 is 0.143, that is 14.3. Here we have to substitute 0.143. Then we are obtaining dry density as 1.88 gram per centimeter cube. Likewise, we can calculate all other values. Next column, that is rho D0, is we are calculating in order to draw the zero air void line. We are having an expression in case of zero air void line as rho D0 equal to G rho W by 1 plus GW. Then we can substitute instead of G, which is given as 2.7 into density of water is 1 gram per centimeter cube. Then 2.7 into 1 divided by 1 plus 2.7 into water content. So we get 2.7 divided by 1 plus 2.7 into W or omega gram per centimeter cube. When we are substituting a water content 0.10, we are obtaining rho D0 as 2.13. When we are substituting in this equation water content as 0.12, we are obtaining rho D0 as 2.04. Likewise, we can calculate all other values. So, by using this tabular column, we can draw our compaction curve and zero air void line. In x-axis, we are taken water content and y-axis, we are taken dry density. In our given values, water content starts from 10%. So, I am here started from 9 in order to mark all other water contents. And our dry density starts from 1.75. So, I have started it from 1.5. So, for a water content equal to 10%, we are having dry density as 1.75. So, we are obtaining this point. And for 12% water content, our dry density is 1.87, and I have marked a point this. And for water content 14.3% and dry density equal to 1.88, we have got a point this. And for 16.1% water content and 1.83 dry density, we have got this point. And for water content 18.2% and dry density 1.75, we have got this point. By combining these points, we are obtaining the compaction curve. Next is zero air void line. Here, for 10% water content, we have obtained a value of 2.13. So, I have marked this point. And for 12% water content, we have obtained a value of 2.04, and the corresponding point is this. And for water content is equal to 14.3%, I have marked this point. And for water content is equal to 16.1%, I have marked this point. And for water content 18.2%, I have got this point. By combining this point, we are obtaining zero air void line. Next, our third question is the degree of saturation at maximum dry density. From our compaction curve, we have obtained a maximum peak point this, and the dry density corresponding to this point is 1.89 gram per centimeter cube, and the corresponding water content or moisture content is 13.5%. So, our maximum dry density is 1.89 gram per centimeter cube, and our optimum moisture content is 13.5%. So we have to find the degree of saturation corresponding to the maximum dry density. That is for 1.89 gram per centimeter cube. So we are having an expression rho d is equal to G rho W by 1 plus E. In this expression, instead of E, we can substitute G W by S. Then rho d is equal to G rho W by 1 plus G W by S. From this, 1 plus G W by S is equal to G rho W divided by rho d. By substituting G as 2.7 and rho W as 1 and rho d is equal to 1.89, which is equal to 1.428. So we are obtaining a value G rho W by rho d is equal to 1.428, which is equal to 1 plus G W by S. From this, G W by S is equal to 1.428 minus 1, that is equal to 0.428. G W by S is equal to 0.428. Then S is equal to G W divided by 0.428. G is equal to 2.7 and W is the optimum moisture content, that is 30.5%, which is equal to 0.135. Then S is equal to 0.135 into 2.7 divided by 0.428, which is equal to 0.852. Okay, thank you.